Hey everybody, welcome into Mr. Stoker's paternity leave video lesson. This is video lesson number 5 now. Today we're going to kind of cycle back to square roots, but it's going to be a bit more involved than we've been in the past. Here we're going to actually be doing some math operations with it. Items you're going to want for this particular lesson, you're going to want the Alex assignment open. Hey everybody, welcome into Mr. Stoker's paternity leave series of video lessons. This is number 5. We're going to revisit square roots and some operations involved with them today. Shouldn't be too bad. In order to be ready to go for this assignment, though, you are going to want to make sure you have a calculator ready to go and this particular slide in your interactive notebook, okay? Cohen, thanks for letting me borrow your notebook. Appreciate you. Okay. It shouldn't be too painless, but we'll work through it. Okay, so for the first 4 sets of problems, it's just simplifying using addition and subtraction of numbers with square roots. Now, anytime you have a number or a square root that's not a perfect square, we like to leave that as just the number underneath the perfect square. You know, it's kind of like fractions where it's simplified. It's also like a variable, in the sense that we kind of just have it there, but we just, combine like terms, right? So if you think of it like equation solving, where you have, a coefficient and a variable like 3x plus 4x, you could add those two together to give you 7x. The same thing can kind of happen here when we're talking about simplifying. Basically, what we're worried about are the two numbers out in front of the radical symbols. Here it's 8 and 5. So to solve this, really all I'm going to do is 8 minus 5, and that will give me 3, and then I'm going to enter square root of 13 for my answer. And if this was addition, which some of these will be, you just add the numbers instead of subtract. So the first 4 are pretty straightforward, okay? Number 5, I'm going to pull up the example before we go do ours. So number 5, one of the key things to remember is that you can use this property, the product property of square roots. Basically, it's saying if you have the square root of this number times the square root of this number, you can simply multiply them together, okay? And you'll get the number underneath the square root symbol, okay? Now, the key is this part right here. As long as this number can't be divided by a perfect square other than 1, it's considered simplified. We'll get into when it doesn't happen in the next couple examples, okay? So in this case, the square root of 2 times the square root of 7, we know it's 14. All right? Now, that's fine, okay? So let's go and look at this one. In this case, we have the square root of 7 times the square root of 5. Okay, so that answer would just be simply the square root of 35. All right, the only perfect square that divides 35 evenly, okay, is 1. And again, why did I want you to have that? Well, think about this. I can do 35 divided by 1. That works. I can't do 35 divided by 4. Okay, it doesn't divide evenly. I can't do 35 divided by 9. I can't do 35 divided by 16. I can't do 35 divided by 25. And now 36 is too big. Okay? So the first 5 perfect squares don't divide 36, okay? Or 35, so that's how I know it's simplified. All right. Now let's move to number 7. This one is a bit different. Here, we're going to go in the reverse. And again, I'm going to pull up the example because it's a little bit easier to see it this way, okay? So here they're asked, the sample question is, simplify the square root of 54. Well, going back to what we just kind of talked about where, we know we can go back and forth between having this broken down, right? So what you want to do when you're asked to simplify is look at this number and see if there is look for the largest perfect square that will divide this number evenly. And in 54, it's 9. So what I could do is rewrite this as The square root of 54 is equal to the square root of 9 times 6. It's equal to the square root of 9 times the square root of 6. And then I evaluate the square root of 9, and that's 3. And I know 6 can't be simplified. So my answer would be 3 times the square root of 6. And again here, the number underneath the square root, 6, has no perfect square factors other than 1. So here, coming back to our problem, where we have the square root of 12, okay, what we want to do is, in this case, we're going to bring up our calculator and this, okay? So I know that 1 will divide 12, right? Will 4 divide 12 evenly? Yes, it will. Will 9? No, and 16 is too big. So we know that the biggest perfect square that will divide 12 evenly is 4. So what I could really do is rewrite the square root of 12 as the square root of 4, and then times the square root of, actually, let me back this up. I can rewrite this as the square root of 4 times the square root of 3, and then I could break that down even further as the square root of 4 times the square root of 3. And as you can see over here, see how the values are all still the same number? They haven't changed anything at all? That's because all of these are the same way of writing the square root of 12. The last step that I can do is now evaluate. I can take the square root of 4, that I know, it's 2. And then that's still times square root of 3. We can't do anything with it. 1 is the only perfect square that divides it evenly, so we leave it as square root of 3. And that would be our final answer, 2 times square root of 3. And again, if you look, see how all the numbers are the same. So come back here, and my answer is going to be 2 times the square root of 3. And that is correct. Okay, we're going to jump forward to question 9. Okay. Question 9 here, now we're being asked to simplify the square root of 15 times 5. Okay? Again, bringing up the example here, there's a couple different ways of doing this, okay? So again, they think of it as the square root of 6 times the square root of 8, and we follow all the same little property things that we've done before. That's the square root, 6 times 8 is 48. Then what we start looking for is what perfect square is the biggest that divides 48 evenly. In this case, it was 16. So then I could do the square root of 16 times 3, and that gives me the square root of 4 times 3. So this is one way to do it. There's one other possible way you could do it. But this is a lot easier and more simple. So what we again think about here is we can change this over from, the square root of 15 times the square root of 5. That I could change to the square root of 15 times 5, right? Okay, so there's that. So I can change it to that. Then I can do, 15 times 5. That is going to give me, I believe, 75. Just double check that, make sure it is. So that means I have the square root of 75, not 25, 75. Now I have to start figuring out what square root evenly divides 75. Not just square root, perfect square. We know 1 does, 4 doesn't, 9 doesn't, 16 doesn't, but I know 25 does. So I could probably figure out, 75, I got square root of 75. So what is 75 divided by 25? Does that work? It's 3. Perfect. So now what I'm going to do is break this down and go the square root of 25, since that divides 75 evenly. And then I'm going to multiply that by the square root of 3. And then I can simplify this to be 5. And then still times the square root of 3. And if you notice, again, numbers haven't changed. So come back to my Alex assignment, and I'm going to enter that as 5 times square root of 3. Okay. Then our last one that we're going to do is problem number 13, and this one involves dealing with some fractions. So here, what we're looking at first is, again, we're going to want to break this down and go from looking at it like this to looking at it more like a fraction like this, okay? So here what they did is, here they put it underneath the radical, divided, and then have their number that they're evaluating, okay? For our particular problem, what we're going to do is rewrite this as the square root of 54 divided by 6, the square root of 6. So we're going to think of that with our calculator as the square root of 54 over 6. Now this comes out to 3, but let me explain why that's coming out to 3. What we can look at is 54 divided by 6 is 9. So after I divide 54 by 6, I have 9. Then I have the square root of 9, and that is 3, okay? So that's why for this particular problem, we would have an answer of 3. And I will check that so you can see that it's right. And then for one other one, I'll just show you a different example. That's the same one. We know that to be here. Okay, I have 77 divided by 7. Well, in this kind of problem, what I have to really think about is do 77 divided by 7 first. That's 11. Then ask yourself if this number is a perfect square. If it is, evaluate it. If it's 11, if it's not a perfect square, then you're just simply going to come here, and your answer would be square root of 11. Okay, check that. That's good too. All right. That's all the lessons. Don't forget to look for examples, and have a great day. You have a couple days to get this done, and make sure you take advantage of all the multiple attempts you have to complete the assignment.